So, basically, an assembler allows a programmer, like this dude here, to basically add some cool features to the software he's creating or she's creating, like an app or a game. So it allows you to create some cool features when you're programming an assembler. Let's have a look at some of these features. Number one, comments. What this basically means is that when you're writing a bit of code, you can put a hashtag next to your code with some sentences of English, and that allows other people who are working with you on the game or the app to understand what it is you've actually done. It doesn't show up when you're running the game, it's just there in the background for other people to see. Comments. Number two, symbolic names for constants. Now remember, a constant is literally a value, like a variable, but it doesn't change. You cannot change it during runtime. With a variable, you can change the value. So score can go up and down. But a constant, it stays the same throughout. So imagine you've got a game where you're working out the area of the area of a circle. Pi will be always the same. It won't change. So that'll be a constant. You would use this all the time. Number three, labels for addresses. Now, these three things here literally are there to help the programmer write a program. That's what they're there for, to help a programmer write a program. And what happens is simple. When it gets turned from assembly language to machine code, and you're writing a program and you've got these three things, the comments actually get taken out by the assembler. It doesn't actually pass it on to machine code, so it removes it. It doesn't need it. These comments are just when you're making a program so that other people can see what it is you're doing. And what happens to symbolic names of constants and labels for addresses is that it gets turned into binary code by the assembler. Other cool features which are provided for programmers. Number 4, a macro. And number 5, subroutine. A subroutine is simply when it gets code and puts it into sections, which means that it makes your code shorter and easier to change. A macro is when parts of your code run automatically. So for example, I've got a macro on my PC that if I press the letter Shift AQ in that order, my videos will start recording, they'll be saved after a certain amount of seconds, and then it'll be put onto YouTube automatically without me having to do anything. It can record sequences of what you do and save it so that it's like shortcuts. So, how does this relate to what we're doing? Well, a macro or subroutine, in this case, these two, contains instructions which can be used over and over again in our program which we're making, which, as I said, makes our code smaller, shorter, and more easy to change. Finally, we've got something called directives, which is another feature. Now, what directives are, well, I'll talk about that in a second, actually. And then finally, you've got something called a system call. And what these two bad boys here, they're different to the others. And let's talk about these very quickly. So what they're there for is, they're like bosses. They direct and they tell, for example, memory, how they should be using the files in this program, which has been made by this dude here, or how they should be using the procedures made by this programmer. So, directives in system call literally give instructions to the assembler as to how the finished product should be basically put together. So imagine in a factory you've got all this code which is being made by people. So you've got a bit of code there, you've got a bit of code here by another person. This person in Japan's working on the same game. What these two things here, directives and system calls, what they'll do is simply tell the assembler how to piece all these pieces of code together, all these procedures. I'm going to put procedures here, so that they can eventually be executed. You might have seen .exe next to apps and programs. What that basically means is literally the directives and system calls have told the assembler, this is how we want the code to be put together so that it can be run on other people's computers. Now, directives and system calls do not need to be turned into binary code. So when we've got our wall and we've got our assembly language, comments does not go through this wall and turn into binary. Nah. But the rest of them do. So this one does, this one does, this does, this does. Now 6 and 7 literally tell the assembler how we should piece everything together at the other end. As I said, it directs memory how it should be used or how procedures will be used. So it creates eventually an exe file. So remember that as well. Assemblers create executable files at the end.